Alright, so in number 11, we got two triangles here, JKM and LKM, sharing a side, and we have to solve each triangle, which means we got to find these sides here, and we got to figure out what these angles are. Alright, now we know that's 90 degrees because it's a linear pair with that line, so that makes JKM a right triangle. Now, we could find KM or JK, it doesn't matter which one we find first. We can't use the Pythagorean Theorem because we only know one side. So that means you have to use SohCahToa, or if it's a special right triangle, you could do that. Now if we use 41, alright, KM is going to be the opposite leg, and JF is going to be the adjacent leg, and JK is the hypotenuse. So if we did like the sine of 41, that wouldn't work because it would be KM over JK, opposite, or JH, opposite over hypotenuse, and we have two variables, so we don't want to do sine. If we did tangent, that would be good because then it would be opposite, which is side KM 41 over 9. So we could do this to find KM, or you could have done cosine to find JK. That would have been fine. So what I'm going to do now is just cross multiply. So I get KM times 1 is equal to 9 times the tangent of 41. Now the tangent of 41 is just a number. So if I type that on my calculator, I get it's 0.8692. Then if I multiply that by 9, I get that KM would be 7.8. Alright, so now we know this side right here is 7.8. Okay, so now we have two right triangles. We have JKM and KML. And to find, in both those right triangles, we know two sides. Like in this one, we know this side is 9, and that side is 7.8. So to find this side, JK, since we know two sides, we could just do the Pythagorean Theorem. So 9 squared plus 7.8 squared equals JK squared. Okay, then we could take the square root of both sides. So 9 squared plus 7.8 squared, when you take the square root of that, it comes out to 9 point, oops, I typed in my calculator wrong. It comes out to 11.9. Alright, so now we know this side is 11.9 by doing the Pythagorean Theorem. Okay, and we could also find this side here by doing the same thing because we know all three sides and all two of the sides in that triangle. Now we're looking for a leg, not the hypotenuse, so it'd be a little different. We would do 7.8 squared, and if we call this x, plus x squared is equal to 21 squared. So then you'd have to subtract 7.8 squared on both sides, and then take the square root. So if I type that in my calculator, 21 squared minus 7.8 squared, all under a square root, that tells me this side right here is 19.5. Okay? Now we have to find these missing angles. So this angle here would just be 49 degrees because these three angles have to add up to 180. And then to find angle K, alright, so let's say I redraw this triangle here, where this is 21, that's our right angle, this is 7.8, and this is 19.5. Alright, so let's say I want to find angle K here. I could do sine, cosine, or tangent. It doesn't matter because I know all three sides. Alright, so let's just do sine. So if I do the sine of angle K, okay, so angle K, this is the this is angle K, this is the opposite leg of that, this is the adjacent leg, and this is the hypotenuse. So the sine of angle K would be 19.5 over 21. Now, how do you find angle K? Well, you can't divide by sine, but what you could do is do the inverse, which means to switch K and 19.5 over 21. So the inverse on the calculator will tell you like what angle you would plug into sine to get that as a ratio. So now if I type this in my calculator, sine inverse, or arc sine, sine to the negative 1 power, of 19.5 divided by 21. And it's a special button on the calculator. You can't just raise it to the negative 1 power. You get 68.2 degrees. So that's that angle there. And then once you know that, you can subtract that from 90 to find the other angle, and that's 21.8.